As we get into our next section, the first thing we're going to talk about graphs from inverses from a graph. So this dark line is what you have on your paper already, and this is the graph that we're going to do. So the first thing we do is make a table for that. So this is, we're pulling these points off. So there's our first point, negative 6, 0. And then we have negative 4, 1, 0, 3, 2, 4, and 8, 7. So once we have that on our table, part B said to make the table for the inverse. So that's what we're going to do. We switch our x and y and get our table for the inverse. So we have 0, negative 6, 1, negative 4, 3, 0, 4, 2, and 7, 8. And then we're going to graph these points. And when we graph them, we should get this line right here. All right. From there, it says graph. Okay, we graphed it already. Now, it says, is f of x a function? Well, yes, we would pass the vertical line test here. So the first line is a function. If we look at the pencil one, that's the inverse. Is that a function? Passes the vertical line test. So it is. And how do we know? The vertical line test. And then it says, where's the line of symmetry? Remember, your line of symmetry is always y equals x. So I drew that in a dotted line. And then last thing it says to do is to come up with our equation. I'm going to do the algebraic way. So I switched my x and y already. So as I work PEMDAS backwards, first thing I'm going to do is subtract 3. And that would give me 1/2 y equals x minus 3. To get rid of that 1/2 y, I'm going to multiply both sides by 2. And when I do that, that would give me y equals 2 times the quantity of x minus 3. If I distribute that, I would get y equals 2x minus 6, which looks more like our graph. So y-intercept is negative 6 up 2 over 1. From there, I just want to make sure I have the proper function notation. So I'd have f inverse of x equals 2x, 2 times the quantity of x minus 3, or f inverse of x equals 2x minus 6. Either one works. You don't have both, but either one. So I would like you to take some time and to do numbers 2 and 3. 2 is on this page, 3 is on the next page. For number 2, you are also asked to get the equation. And for 3, you are not asked to get the equation. So just do the points and the graphs. Take a second and go ahead and do that. All right, so here's your answer for number 2 here. Notice we do get a sleeping parabola when we graph our inverse table. So it says, is g of x a function? So our original one, yes, that is. It passes vertical line test. However, our inverse is the sleeping parabola, so that is no, it does not pass the vertical line test. And again, how do we know the vertical line test? As you look at your equation here, just remember you would need plus or minus to get that full sleeping parabola. So don't forget that plus or minus. And this is what we would have for example 3. Just remember when you are making your table for your original, you are working from left to right. So your smallest x value should come first, and then you're flipping those x and y values. And then when you connect and plot those points, you connect from top to bottom. So that's how I got that shape, connecting from top to bottom. Is h of x a function? Yes, the original one would pass the vertical line test. But the inverse, no, right here, these would not pass the vertical line test. So the inverse is not a function. Again, we know by the vertical line test. Our line of symmetry is still y equals x. And that's what we have. All right, so now the horizontal line test. So to determine to determine if a graph's inverse is a function without actually graphing the inverse, you can use the horizontal line test. So if we had just this original graph and we wanted to know, without graphing this other one, the inverse, if the inverse is going to be a function, we do what's called the horizontal line test. So it says that if a horizontal line crosses the graph at one or more points, then the graph's inverse is not a function. So if we looked here, horizontal lines on the original function, a horizontal line crosses at more than one spot, so that means this inverse would not be a function. Okay, so here's some other examples. I'll draw a cubic. So if I draw vertical lines, that's telling me that the f of x, I'll call this f of x is a function because of the vertical line test. However, if I drew horizontal lines, that would also tell me that the graph's inverse is also a function. So I can say f inverse of x is a function because of the horizontal line test. Now let's say I have a parabola. If I did the vertical line test, I'll call this g of x. G of x is a function because of the vertical line test. And without even graphing the inverse, I can do the horizontal line test. And the horizontal line test, since these horizontal lines are crossing at two spots, which is more than one, I know that g inverse of x is not a function because of the horizontal line test. All right, we'll be working the horizontal line test shortly. Have a great day.